Okay, so guys, we're going to do a little bit of review of solving systems of equations in two variables. I have these three problems, solved by graphing, solved by substitution, and solved by the addition method. If you would like to go ahead and try them first on your own, pause the video right here and take a few minutes to try them on your own. When I go through the explanations here in just a minute, they're going to be rather quick. So, solving by graphing means you are taking both of these equations and graphing them on the same coordinate plane to see where they cross. Since this one right here is already solved for y, I can go ahead and use my beginning amount of -7, put a point, and then use my slope of -1 to move down 1 over 1, down 1 over 1. Because this is an equation, remember with equations, you just draw the line, connect the dots, and you are done with that equation. Every point on that line is a solution to that equation. But again, you are looking for the point where both of these lines are true. So you take the other equation and you solve it for y. You get y by itself, because you are going to graph it using the same techniques that we did with the first one. And so we're going to, first of all, add 5x, add 5x. That's going to give me -5y equals 5x plus 15. Then we're going to divide by -5, divide by -5, and I get y is equal to 5 divided by -5 is -1x. 15 divided by -5 is -3. So notice on that one, you begin at -3, and then you move down 1 over 1, and that gives you the same slope and a different y-intercept, so that gives you two lines that are parallel to each other. And parallel lines do not touch. So what would be the solution? There would be no solution for this system. It doesn't mean the points on the blue line don't work for this one. It just means that there's no solution that works for both equations. Every point on the blue line still works for this equation. Every point on the red line still works for this equation. But there is no solution that works for both of them. Now, we also called that inconsistent. That was the name of this type of system. But you do not need to focus so much on that name and forget to actually write no solution. Some of you on your quiz forgot that this is really the important part, understanding that they don't have the same answer. If they do touch each other, then that would be the solution. You would just find the point where they touch each other. There'll be another video that you can watch on graphing as well. The substitution method. Substitution method says I take one of these equations and get y by itself or x by itself and plug the answer into the other equation. That's why it's called the substitution method. You'll notice on this one, it was perfectly set up for substitution, meaning this equation is already solved for y. So if I know that y is already equal to -3x, I can take that and plug that into the other equation. That is the main step when you're dealing with a substitution method, is that you plug it into the other equation. That is the thing that makes this actually work. So please make sure you're careful with that. So you should get x plus, and you plug in -3x where the y is. Notice on the substitution method that I also replace it completely. I don't leave the y there. And so this equation that you get is going to end up being an equation that we did in chapter 1 in the first chapter, when we were dealing with just one variable equations. What is x plus -3x? That's -2x. And then you divide by -2 on both sides. X is -1. After you get one of your solutions for the substitution method, the easiest thing is to take this number and plug it right back into that equation from the first step. Even if you had to solve it yourself, if it wasn't already perfectly set up, whatever you got when you solved it is still going to be very easy to plug in a number to, because it's going to have y equals, and that's what I'm looking for. So I take x and I plug it in here, and I get -3 times -1, which is +3. That means the solution to this system is -1, 3. That means also, like we talked about on the previous problem, that this one would be consistent and independent. That's the name, but that's not the important part. As long as you know the solution, that's the really big key. Now, on your test, I will ask you just a couple little questions about these names, but I'm really wanting you to focus on making sure that you can get the solution to that system of equations. There will also be another video on the substitution method as well. The last method that we learned was called the addition method. Now, some teachers also call this the elimination method, which is completely fine because technically that is what you are doing. You are going to try to make one of the variables disappear. First of all, though, make sure when you're doing this method that your variables are lined up. For instance, in this example, the x's are not lined up. So you need to move the 5x over here by switching the order. And you don't have to do anything weird on this one because they are on the same side of the equation. That's called the commutative property of addition. You can just move the order. If it was on the other side of the equation, you'd have to do things a little different. You'd have to subtract or add it over. Now notice this. On the x's, I already have opposites. I'll do another video where you don't have opposites and show you what to do. But when you have opposites, the variables will cancel out through the addition method. 6y and 6y is 12y. 14 plus 10 is 24. Then all you have to do is solve this little tiny equation here and divide by 12 on both sides, and you end up with y is equal to 2. Just like with the substitution method, if you take this little guy right here and you plug him in, you will find the x value. My suggestion would be to plug it into this one right here. That's just my suggestion. You do 5x plus 6 times 2 equals 10 because y is equal to 2. Then you just solve this single equation here, single variable equation, You get 6 times 2 is 12. You subtract 12, and you get 5x is equal to -2. Then you divide by 5, and you get x is equal to -2/5. Yes, as a decimal, that's -0.4. But just make sure you're careful with your decimals, especially in the middle of a problem. Don't round any decimals. At the end of a problem for the answer, it's not as big a deal. So this one crosses at -2/5 and 2. Notice again that this one would also be consistent and independent, just like the one before it, because it has a solution. If it were infinite solutions, it would be consistent and dependent. Remember, we joked about the dependent boyfriend and girlfriend who are always stuck together, like those two lines would be if it's infinite solutions. So that's a quick overview of all three methods, the graphing method, the substitution method, and the addition method. I am also going to make a few other videos of individual problems with these methods, and then try to throw up maybe some videos as well on inequalities and hopefully a 3-variable system, as long as time constraints don't get in my way. Hope these help. Let me know if you need any help with anything else.